Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at exponential rates using the base e. So by the end of this lesson, you'll be able to use the natural log in both algebraic and practical contexts. Let's have a look at a few examples. Question 1. The number b of bacteria in a lab culture is growing according to the formula b is equal to 4000 e to the 0.1 t, where t is the time in hours after the experiment was started. Answer these questions correct to 3 significant figures. How many bacteria are there after 5 hours? So after 5 hours, the number of bacteria is going to equal to 4000 e to the power 0.1 times 5, because t is 5. So we can put that in our calculator. 4000 e to the power of 0.1 times 5, which is 6594. Now the question says to 3 significant figures, so we want to round it to the nearest 10, so 6590. Okay, that's correct to 3 significant figures. Find the rate dB dt at which the number of bacteria is increasing. So what we need to do here is we actually need to differentiate this. So if we have b is equal to 4000 e to the 0.1 t, then dB dt, well, what do we get when we differentiate an exponential? So I'm going to bring out my reference sheet, which you'll have during your exams. I'm going to scroll down to where the differential calculus is. So when we've got y equals e to the power of f of x, then when we differentiate it, we get f dash of x in front of the function e to the f of x. So we need to differentiate whatever is in the power and bring that out to the front. So according to this, here's our f of t. We need to differentiate that and bring it out to the front. When we differentiate that with respect to t, we get 0.1. So technically we've got 4000 times 0.1, which is 400. And then we write e to the f of t. Okay, so that's the rate at which the number of bacteria is increasing. At what rate are the bacteria increasing after 5 hours? So we just worked out the gradient function, which will tell us the rate of increase. After 5 hours, so when t is equal to 5, the rate is equal to 400 e to the power 0.1 times 5. 400 e to the power of 0.1 times 5 is 659, and this is bacteria per hour. Remember, we're talking about a rate. Now I'm going to say this is approximately equal to, because it's not exact. And I'll probably do the same thing up here. Okay, question D. What is the average rate of increase of the first 5 hours? So what that means is we need to work out how much bacteria there was in the first, well, when t is equal to 0. We've already worked it out when t is equal to 5, and then we can just work out the average. So when t is equal to 0, how many bacteria were there? Well, according to this, we needed to use the formula. Bacteria is 4000 e to the power 0.1 times 0. 0.1 times 0 is 0, e to the power 0 is 1. 4000 times 1 is 4000. So at the very beginning there were 4000. When t is equal to 5, well, we already worked this out. We said that the number of bacteria was 6590. So now we can work out the average rate of increase Well, from 6,590 minus 4,000 divided by the 5 hours it took. $6,590 minus 4,000 to begin with over 5. 518 bacteria per hour. Okay, so you might be thinking, oh, why are these numbers different? Well, here the 659 bacteria, that's the instantaneous rate. Okay, because it's not actually growing at 518 bacteria every single hour. That's the average. In fact, in the first hour it's probably less than that, and slowly is getting more and more and more. And by the time 5 hours has increased, it's now increasing at this rate of 659 per hour. When are there 10,000 bacteria? So 10,000 is equal to 4,000 e to the 0.1 t, right? That's the number of bacteria over here. So I'm just going to divide both sides by 4,000. 2.5 is equal to e to the 0.1 t. I'm going to take the natural log of both sides. So ln of 2.5 is equal to ln of e to the 0.1 t. That means that this power can come down to the front. So let's just write that out. 2.5 is equal to 0.1 t ln of e. But ln of e is just 1, right? Log base e of e, that's just 1. And so now we can say that t is therefore equal to ln of 2.5 divided by 0.1. So let's put that in our calculators. Ln of 2.5 over 0.1, which is 9.16 hours. Okay, and this is 9.16 hours after the experiment was started, because according to the question, it says where t is the time in hours after the experiment was started. So if you want to add that in, I'm happy for you to do that. After the experiment started. Alright, question F. When are the bacteria increasing by 10,000 per hour? Now this says 10,000 per hour. That's a rate. So that means we need to be using dB dt. So if dB dt, the rate, what's the formula for that again? It's 400 e to the 0.1 t well, if the rate is 10,000 is equal to that, then we can do exactly the same thing as before. So I'm going to do 10,000 divided by 400 this time, which is 25. So 25 is equal to e to the power 0.1 t. I'm going to take the natural log of both sides, so ln of 25 is equal to 0.1 t. Okay, so I skipped a step here, because when I take the natural log, I can bring down the power, and ln of e is just 1, so it's just 0.1 t times 1, which is just 0.1 t. And therefore, t is equal to ln of 25 divided by 0.1. ln of 25 over 0.1, which is 32.2. 32.2 hours after the experiment started. So the bacteria is increasing by 10,000 per hour. That's heaps. So if you think about it, right, at the very beginning, question C, After 5 hours, it's only increasing by 659 bacteria per hour. But after 32.2 hours, it's increasing at a rate of 10,000 per hour. Okay, so that's exponential growth. Alright, let's have a look at question 2. The concentration C is equal to 2000 e to the negative 2t of a chemical is varying with time t in years. Now this negative power here tells us it's not going to grow, it's actually going to decay. It's not going to increase, it's going to decrease as time goes by. So find the concentration when t is equal to 2. Well, when t is equal to 2, the concentration is going to equal to 2000 e to the power negative 2 times 2. Okay, just sub it into the formula. And what do we get? 2000 e to the power of negative 2 times 2. 36.63. I'll just do it to one decimal place. 36.6. Okay, question B. Find as a function of t the rate dc dt at which the concentration is changing. So now we want to differentiate this. If c is equal to 2000 e to the negative 2t, then dc dt, we need to differentiate this. So we have a look back at our formula sheet. We've got f of x, or f of t in this case, and we need to differentiate it and bring it out to the front. So when we differentiate this, we get minus 2. So we've got 2000 times minus 2, that's minus 4000. And then e to the f of t. Okay, so that's dc dt. Find the rate at which the concentration is changing when t is equal to 2. So just to refresh your memories, whenever we differentiate, we're finding the gradient function, or we're finding the rate of change. So what we've done here is we've differentiated it, and with the gradient function, we can work out the gradient along any point of a curve. We're pretty much doing the same thing here, okay, except it's just a rate of change. Okay, so we can sub in any value for t, and it'll tell us the rate at which the concentration is changing in this case. So when t is equal to 2, dc dt, the rate at which the concentration is changing with respect to time is going to equal to negative 4000 e to the minus 2 times 2. Okay, I'm using the formula up here because that's the rate. Okay, so let's put that in our calculators. Negative 4000 e to the power of negative 2 times 2, which is negative 73.26. And whatever the units is, it could be grams, it could be milligrams, not too sure, but whatever it is, I'll just say units per year, because according to the question, t is in years. Okay, last question for this video. We've got find the average rate of change over the first 2 years. So over the first 2 years, we want to know how much concentration there was after 2 years. So when t is equal to 0 and 2. So when t equals to 0, how much concentration was there? C is equal to 2000 e to the power of negative 2 times 0. Okay, because it's e to the negative 2t. So I sub in 0 there, and I get an answer of 2000. Could be 2000 grams, 2000 milligrams. When t is equal to 2, C is equal to, have we already worked this one out? We have, right? Question A. Find the concentration when t is equal to 36.6. 36.6. So we want to find an average. Average rate of change for the first 2 years is going to equal to how much after 2 years minus what it started with divided by how long it took. So after 2 years we've got 36.6. We started with 2000 and it took 2 years. So that's minus 981.7. I'll just say units per year. And this is on average. Okay, so that's it for this video.